Hello students. So in this lecture we are going to start the chapter number 1 of class 12th, relations and functions. See, in class 11th you have already studied what is relation. So if we recall what was the relation, so in the class 11th you have studied Cartesian product. Do you remember what was the Cartesian product? Okay, what was the Cartesian product? Cartesian product. So Cartesian product was what? Suppose if there are two sets, if set A and set B, there are two sets, and if you take set A as some elements in the set A, suppose there are two elements 1 comma 2, and the set B, suppose again there are two or three elements, for example I will say A comma B. Then how you used to calculate Cartesian product? A cross B. The Cartesian product was the collection of all the possible ordered pairs. So here you have 1 2, and here you have A comma B. This is A, this is B. So how you used to calculate Cartesian product? Cartesian product, 1 can go with A, 1 comma A. Also 1 can go with B, 1 comma B. Then 2 with B, 2 with A, and 2 with B. So this is how you used to calculate the Cartesian product. So just after the Cartesian product you have studied the relation. So what was relation definition? Do you remember relation definition? I think it is any subset of Cartesian product. Okay, any subset of Cartesian product is a relation. Okay, so if I take any subset from here, we will get a relation. So what we going to study in this class 12th? Already you have studied relation. So here we will going to study types of relation. Types of relation. Types of relation. Here we will cover types of relation, and we will going to cover three types of relation. One is reflexive. Just hear me properly. Reflexive relation. Once it is done, then we will cover symmetric relation, and after that we will cover transitive relation. Three main types of relations we will cover. Then we will extend the class, and then I will let you know the more detail about the chapter. Okay, so first one, what is reflexive? What is reflexive? What is reflexive relation? Okay, so a relation capital R on a set capital A. See, in the relation your set is very important. What is the set? So we will be always focusing on the given set. So a relation R on a set A is said to be reflexive if each element is related to itself. Okay, what we mean by this? Each element is related to itself. Okay, or mathematically I can write A comma A belongs to R for every A belongs to capital A. Okay, let me clear this with one example. Okay, with one example. Okay, suppose if R1 is a relation on set A. In the set A there are two elements 1 comma 2 given by R1. Okay, 1 comma 1, 1 comma 2, and 2 comma 2. Okay, now is this reflexive? My question, is this reflexive? Is this reflexive? Now see the definition. Definition says that if each element here one more line, each element of set A, okay, of set A is related to itself. Now you have to see what is your set A. Here your set A is 1 comma 2. It means this R1 will be reflexive if each element of this set A is self related or related to itself. It means 1 should be related to itself. It means in the relation we have to look 1 comma 1. It is already there. Now we have to see 2 also self related. It means 2 comma 2 belongs to R1, has to in R1, then only it will be reflexive, and it holds for all the elements in the set A. Okay, here in the set A we have only 2 elements, so 1 1 and 2 2 in R. It implies that it is reflexive. So yes, it is a reflexive relation. Yes, it is a reflexive relation. Suppose same set A and I am changing the relation. Another example, if R2 is a relation on a set A 1 comma 2 given by R2 is 1 1 1 2. So is this a reflexive relation? Now you need to check again definition. See here we have 2 elements. It means 1 should be related to itself as well as 2 should be related to itself. It means I have to look 1 comma 1 and 2 comma 2. 1 comma 1 is present but 2 comma 2 is not present. It implies that it is not a reflexive relation. Not a reflexive relation. Okay, so is it okay now? How to decide reflexive? For the reflexive, every element of the given set A is related to itself. This is a reflexive relation. Okay, clear? Okay, fine. We will do more examples and more questions in the upcoming lectures. Next, symmetric relation. Symmetric relation. Okay, what is symmetric relation? So a relation R on a set capital A is said to be symmetric if whenever, okay, not always, whenever AB, ordered pair AB belongs to relation R, then B comma A also belongs to R. If this condition is fulfilled, we can say our relation is a symmetric relation. Okay, can we take some examples? If I say the given set A is what? A set of siblings in a family. Okay, I am taking a set of siblings in a family, and R is the relation such that ordered pair A comma B such that A is brother of B. Now we need to check, is it symmetric? Is it symmetric? So for the symmetric relation, whenever AB belongs to R, then BA has to be in R. Okay, suppose A comma B belongs to R. It implies relation is what? A is brother of B. A is brother of B. So can I say from here B comma A also belongs to R? Tell me. If A is brother of B, it means A surely is a male. But B may be male or may be female. In both the situation, this condition is fulfilled. So it implies that we cannot be 100% sure that BA always belongs to R. It implies that the relation of brotherhood in a same family is not a symmetric relation. Okay, so BA need not be in R. It implies It is not a symmetric relation. Not a symmetric relation. Any other example if I write? Suppose a relation R on a set capital two numbers in the set A1 2. Okay, and relation I am defining such that 1 comma 1, 2 comma 2, 1 2, 2 1. Okay, is it symmetric relation? Is it symmetric? So what is the condition for symmetric? Whenever in the relation AB, then BA has to be in R. So we have to check for all the elements present in the relation. Okay, so okay, 1 1 belongs to R, so it's reverse. What reverse? Again 1 1, it's already there. 2 2, if you take the reverse also, again it is same. 2 2 belongs to R. Now if I take 1 2 belongs to R, then it's reverse. It's reverse pair. 2 1, 2 1 already there. See, 2 1 already there. If I take 2 1, it's reverse. 1 2 already there. It means this is a symmetric relation. Okay, this is a, yes, it is a symmetric relation. Now since we already have covered the relation reflexive, so can you tell me, is it reflexive relation? How to check reflexive? So for the reflexive, we will check every element of set A, of given set A, should be self related. It means we have to check 1 1 and 2 2. So 1 1 is there, 2 2 is there. It means this is reflexive also. Okay, this is reflexive also. Now transitive relation. So a relation R on a given set A is transitive if AB comma BC belongs to R, implies that A comma C belongs to R. Okay, for each ABC belongs to capital A. Okay, so whenever, see, for transitivity we will be always looking for connecting pairs first. AB, then second pair starting with B ending with C. So if such condition we can get in the relation AB and BC belongs to R, then A and C, first and last element, also belongs to R, then only we can say it is a transitive relation. Okay, and it should fulfill for all the connecting pairs. Okay, I hope you can relate. Connecting pairs means ending with B, starting with B. That's why we are saying connecting pairs. Okay, so see, in transitivity we have to solve more examples, otherwise you might confuse later how to decide transitive. So I'll write some relation first. Okay, example. Let given set A is 1 2 3. Okay, and I'm taking some relations R1, R2 and R3. Okay, here I'm taking R1 is 1 comma 1, 1 2, 2 1 and 2 2. Okay, this is R1 on the set A. Okay, these all three relations I'm taking on the set A. Another one 1 comma 1 comma 2, 2 comma 3 and 1 comma 3. Okay, R3 I'm taking 1 comma 2 only. Now we have to check all the three relation for transitivity. Okay, and we will try to understand the definition. So see, first one R1. See, for R1, whenever we check transitive, we have to look for connecting pairs. Okay, and we have to look for all the possible connecting pairs. So I will start with this element 1 comma 1. 1 comma 1, it is ending with 1. So for connectivity, next element should start with 1. So in that we have only this. Okay, 1 comma 2, then 1 1 1 2, it is connecting pairs. So it means 1 comma 2 has to be in R. So already 1 2 is there. It means for this it is satisfying. Okay, this first pair is done. Now I will start with 1 comma 2. another element 1 comma 1 comma 2. Then for the connectivity next element should be start with 2, so we have this choice 2 comma 1. Then first and last 1 comma 1 belongs to R. Okay, if we take this element 1 2, then starting with 2 2 sorry 1 2, now 2 2 2 2, then again 1 comma 2 is there already 1 comma 2, so holds. Now 2 1 1 1, then 2 1 is there. Okay, so it means it is a transitive for all the situations whenever AB and BC belongs to R, AC also coming in R, it means it's a transitive relation. So R1, yes, R1 is a transitive relation. Okay, R1 is transitive, yes, it is a transitive relation. Yes, now let's check for this R2, is it transitive? So again for the transitivity we will try to look for connecting pairs. So here we'll start with first element 1 comma 2. So for connectivity now second element should start with 2, so we have only one choice 2 3 2 3. If it is transitive then 1 comma 3 has to be null, 1 comma 3 has to be null, and yes it is already present. So for this pair it is okay. Okay, now we cannot say it is transitive, we have to look for all the connecting possible pairs. Now I'll check another pairs. If I start with this element 2 comma 3 2 comma 3, so is there any element starting with 3? No connectivity, so we cannot check this. Now if I start with 1 3, then there is no element starting with 3, so it means yes it is also transitive. We have checked already all the connecting pairs. Now what about this? What are you thinking, is it transitive or not? Yes, it is also transitive. In short you can remember singleton relation is always transitive. Okay, always transitive. And why it is transitive? Why definition it is transitive? Why definition? By default it is transitive because transitive definition says that whenever AB and BC belongs to R, it implies AC belongs to R. This is definition of transitivity. But in this there is no connecting pairs AB and BC. So how can you say A comma C does not belongs to R? It means the information is insufficient. We are not having any connecting pairs. It means you cannot decide they are transitive or they are not transitive. So in mathematics, we are taking the positive statement that by default it is okay. By default it is transitive. Okay, clear? Okay, and next exercise questions we will cover in the next video.